Everybody good there? Okay?
Yes.
Alicia, Joshua is. And Zane. Alright, let's go down and do one of these where we've got to plug in variables instead of plugging in a number. So, like number 9, for example, we are plugging in 5a plus 4. So for 5a plus 4, we're plugging that into k. So when I do that, I'm going to have 3 minus 2 times 5a plus 4. All right, and we probably want to simplify that a little bit before we plug it into f. So we could distribute that to 2. 3 minus 10a minus 8. And that is going to be negative 10a minus 5. And that's as simple as you're going to be able to get. You could do negative 5 minus 10a if you'd rather. And then so this needs to be plugged into f, which is 4x minus 5. So I've got negative 10. I'm sorry, I'm doing that backwards. Yeah. I need to get rid of that f altogether. I will have 4 times negative 10a minus 5 minus 5. I will distribute that 4. I'm running out of room here. Just going to have to go to the next problem. I'll get negative 40a minus 20 minus 5. So I'll get negative 40a minus 25. Everybody okay there? We also are going to have where we're just going to plug an equation into another equation. So, like, let's do number 11 right there. For 11, we are plugging f into g. So that means 4x minus 5 gets plugged in the place of the x in our g function. Whichever one's closest to your x is the one that gets plugged into the other. So we would have 4x minus 5 squared minus 2 times 4x minus 5 plus 4. What is 4x minus 5 squared? $16x minus what? No. It's what we want to think it is, but it's not. Anybody know what 4x minus 5 squared is? No, but you're getting there.
Negative 40x plus 25.
Negative 40x plus 25. So let's remember how to get that. When you have 4x minus 5 squared, that is, excuse me, 4x minus 5 times 4x minus 5. Right. So to multiply that together, you got 4x times 4x is 16x squared. Then you will multiply 4x times negative 5, which will give you negative 20x. And then you'll have to distribute this negative 5 also. So there's another negative 20x, and then plus 25. And so when I combine those two middle terms, I'll get 16x squared minus 40x plus 25. Now, for what we're doing here, if you need to write that over to the side, that's perfectly okay. I would prefer for you to be able to do this in your head. However, whenever it comes down to being fast or being correct, I would rather you be correct. So do what you need to do here. The way that I do this is I call it square double squaring for that. Note, like to get that first term, you're going to do 4x times 4x. That's square in the first term, right? Square this, that gives you 16x squared. Then you are going to multiply the two things together and double it, right? Because here you're doing 4 times negative 5. Here you're doing 4 times negative 5. You get the same thing, so you're doubling it, right? So do 4 times negative 5, which is negative 20, and then double it, which gives you negative 40. And then square the last term, you get 25. So the more we can do that in our head, the better, because it's going to be just like this little tiny piece of bigger stuff that we're doing moving forward. So we've got that. Now we just need to distribute that. Negative 2, that's going to give us negative 8x plus 10, and then plus 4. And then you will combine your like terms. So 16x squared minus 48x plus 39. Everybody okay here? All right. I love what he's done with the back page. It's so good. The back page is just wonderful as far as making you think. Because talk about like some different representations. He's thrown all kinds of stuff at you here, right? You got two graphs. You have a table. You have a piecewise function. And then I almost missed this during second period. You have a verbal description of the function m. So he has given you all kinds of different things that you have to use for this back page. So it is really good as far as making you think about what you're doing for these problems. F of g of 4. We would first find g of 4. G is this graph on the right here, right? So to find a value from a graph, we're going to go to where x equals 4. We're going to go up, find the point on the graph. All right? Right there, my x coordinate is 4. My g of x coordinate is the y coordinate. So it would be 3. So that means this is f of 3. Okay? Then I have to find f of 3. So now I'm looking at the graph on the left here. My x coordinate is 3 right here. So I go up to find that point on the graph. And then f of 3 is your y coordinate. So you look over here, that is 2. So you get 2 for that answer. I believe you did some of this on Delta Math, didn't you? Yeah. Okay. Now, what you probably didn't see on Delta Math, I don't think they had tables on Delta Math, but tables are pretty straightforward for that. Let's do 19. First, it asks us to find f of pi. Oh, so what is that going to be? It's 2. Thankfully, like, they gave us 3.14, which would be really hard to do if they'd given us a slanted line, right? Yeah. But that hits right here on this horizontal section. So the y coordinate is just 2. So we're looking for p of 2. P is my table. What is p of 2? It is negative 1 right here. Because we're looking where our x coordinate is 2. P of 2 is the y coordinate that goes with it, so it would be negative 1. Let's do one with that piecewise function. Let's do 21. You got to find h of 0 first. So h of 0, how do I do a piecewise function? What do I do? There's so much going on there. Very good. And I can tell where it applies by looking at the restrictions over here on the right. So it'll be the top equation, right? So if I do 8 times 1/2 to the 0 power, what am I going to get? It's just going to be, not 0. It's going to be 8. Because what is 1/2 to the 0 power? It is 1. Anything to the 0 power is 1. It feels like it should be 0, but it's not. All right. Then I've got to find g of 8. So I'm going to look at my g graph. 8 is right here. There's the point that goes with it. What is g of 8? It's 4. All right, let's find a crazy one that does m. Let's do 26. 26. Can we do? Well, let's do 26. 26 is weird in 2 ways. Number 1, we got to use the, we got to do the, we've got to do the verbal explanation, and we're doing m of m, right? It's like you're plugging something in that equation twice. So here's what I did with them in second period. M is this long explanation. M depends on G, right? I'm going to write an equation for this, for M of X, okay? And so M is the result of applying 3 transformations to G. So I've got G over here, and I'm going to do some different stuff to G, right? I might need to add, subtract, inside or outside the parentheses, and I might need to multiply inside or outside the parentheses. So there is a vertical dilation by a factor of 2. What should I do to G? 2 out front. Multiply by 2. Vertical tells me that it's outside. Dilation means I'm multiplying there. Okay? And I should have an X in here. I have a vertical translation by -3 units. That'd be down 3 units. What do I do to accomplish that? Outside, -3 goes right here. And then horizontal translation by 1 unit. I would like this better if they said right 1 unit, but I'm going to assume that because it's positive, they mean right. They would have put a negative there if they did not. So what do I need on the inside? -1. Okay. All right, so I need, first of all, to find m of -1. So m of -1 is going to be 2 times g of -1 minus 1 minus 3. And that is going to be 2 times g of -2 minus 3. So now I've got to go to g and find what g of -2 would be. And so g of -2, that's right here. That's this point. What is g of -2? It is 3. That is our y value. So I'm going to run out of room on this too. 2 times 3 minus 3 is 6 minus 3, which gives us 3. Are we done? No, because we've only found m of -1, right? Now, this was m of -1, and we found this right here was 3. So now I'm really out of room, so I know you might be too. He didn't leave a lot of room on this worksheet. If you need scratch paper, that'd be fine. Or if you need to do some of it in your head, that's okay. So if I'm doing m of 3, that is going to be 2 times g of 3 minus 1 minus 3, which is going to be 2 g of 2 minus 3. And g of 2, we've got to go back up here to the graph. G of 2 is right here. What is g of 2? 1. So we got 2 times 1 minus 3. 2 minus 3 is -1. Somehow, to me, it is a little disappointing that m of -1 is still just -1. You didn't even get a different number for that. Okay. Questions on anything? 19. Yeah. So on for f of pi, you're looking at this graph right here, and so pi is like 3.14159. So that's somewhere here between 3 and 4, a little closer to 3 than it is 4. So we're going to go to where that point hits on our graph, which would be this point right here, and then the y coordinate of that point is our value of f of pi. So that is 2. And then we have to do p of 2. P is the table. So now we're looking at the table. And the number inside of your parentheses when you're evaluating thing is your x value. So we're looking where x equals 2. And then p of 2 is the y coordinate on that table. So negative 1 for that.
So when it says evaluate if possible, for example, number 20 lands on the hole. How would we write that?
Undefined. Yeah. If you end up on the hole, you're going to put undefined, and that is probably why they put if possible in the directions. Now, I say that. What about f of 6? What is f of 6? F of 6 is 2. F of 6 is not undefined. You do have a hole on this side, but you got a dot there. But f of 4, if you find yourself having to do f of 4, that's undefined. So you would say undefined.